again, as always, here Tune, and my name is Desika Prabhakar, founder and director of the Purpose Foundation, and we have our darling Lakshmi here, COO of the Purpose Foundation. So today, this special session is dedicated to the top 5 teams who are going to give us their updates and share with us the progress so far.
This is a direct combustion. This will emit a lot of and what temperature you are heating up, what kind of material you are using to get it up, and how you are doing the oxidization.
No, sir, now we have a plan to burn some waste like a 10 kg per day.
No, you can't just burn some waste. What I'm trying to say is the burning waste is it is against to the environment. But what method you are burning, how technically, what is the innovation you did it, and how you are solving the emission problem. That is the matter. And the flue gas treatment, it is not that nobody will, no government bodies will not approve this method. Because you can't just burn, because what kind of filtration and how much emissions you are taking out, and how to make sure that emissions this will, because you the simple water scrubbing never going to work. Even the government or even any pollution board in India or anywhere, they don't approve that this technology. But what temperature you are burning it, and how you are reducing the NOx and SOx. And you mentioned pyrolysis and gasification, where you are not using that, where you are implementing in the project, and what kind of pyrolysis and what kind of gasification you are using it.
Not planning to do for an inorganic now.
No, that is the major thing, because the project right now, the organic, it is commercially available, my friend. It is, everything is there, but you just apply your innovation and find the solutions which is having a problem. The major problem today is the plastics and other inorganic things, and that how you are going to handle it. See, when in academic, when you are doing a product and when you are going to a research, we have to find the solutions which is not found yet. Or even the existing solution, how to make it simple. These two things you can do it. So these are my suggestions, that you have to mainly focus on the core technology and technical things and innovation.
So, but here by the combustion chamber, the flue gas in the outlet, we use a container, a polluted gas container. Then we use an ESP, electrostatic precipitator.
At each point, they have to test what level of gases are there in the flue gas. So if they test, then they can easily compare what the amount of gas that is generated in this method with the previous method, what has been, as sir is saying that it will not come up to the mark. We will definitely change the method. So they have just...
No, it will not come to up to the mark. What I'm saying is, in flue gas, you can't extract any gases which is fuel.
Right, sir.
In flue gas, it is not at all possible. It is, if you are just burning something, you go to the chimney and you are just trying to extract gas, because there is no gas in that, because it's already burned. And 500 to 600 degree temperature, it is never going to work. And another point is, you have to have a clarity which kind of technology you are going to use it. It is not just waste to energy, it's not a concept, but what you are going to use it, what kind of material you are going to use it. Like
biomass gasification and electricity generation is already there, but the main problem is lying in the SOx NOx emission. So we will work on that.
Biomass gasification does not have that much of NOx and SOx.
Okay.
Only it has in the inorganic plastic things, if you are burned out, it has the NOx and SOx.
Right.
So the biomass gasification, there is a very limited market, and it is already, if you are doing a proper combustion in the biomass gasification, you don't need to be put like even electrostatic precipitator, because it is does not have, because it's a natural organic, it does not have NOx and SOx.
Ma'am, firstly, the in the segregation process is itself is a problem. So first, if you can effectively filtrate filtrate the waste, then only we can have the chance of getting less SOx NOx emission. The electrostatic precipitator or the carbon roller or the any kind of silicate refiner or CC units. and economizer. All these things are there for the filtration techniques. So if you can check over there effectively, then in the management process, SOX management process can be and
So to reduce that, what kind of technology that you are going to inbuilt? It's the end of the day, it has to be have a commercial value.
So first we will start with the Waste Warrior team if you're there. So our last discussion was that you have finalized to take upon PVC as a target and to look at recycling options, look at problems in PVC space. So you are supposed to submit a report or you are doing your research on it. So please tell us what is the progress so far and what have you finalized on building and how we can support you further. So you can go ahead, Waste Warrior team.
Ma'am, as usual, we said last session that we will focus on the PVC, the
Yes.
PVC waste materials.
Yes.
So uh, we work on this process and uh, we held on the PVC treatment and all to produce products and the methane gas and all. Can I show the
Yeah, yeah.
rough report or
Sure,
the
sure. Whatever you have prepared so far, please share with us. Then we have a couple of questions for you and your team. So we will note it
yes,
down and then we will work out. Please share your
yes, ma'am.
screen, whatever. Yeah.
There is a process that hydrothermal dechlorination as usual, as we I said in last session. Then
Yes. Yes.
like the PVC is the big challenging part for the chlorine presence of the chlorine and all. So there are some hazardous chemicals which is formed by the recycling for by this recycling process or their treatment process. So there is a process where we absorb or collect this chlorine from the PVC and we make some byproducts and all. We use the CL acceptors and all. There is a this is a block diagram. The chlorine acceptor. This is like used as a ethylene or the aromatic compounds and with and boil the PVC with the 200 to 300 degrees Celsius for the chlorine transfer. Then the hydrogenalysis process, which give the methane and the H2 gas. And there is also solvent forms which is industrially used. There's the C2H2Cl2. That's how the process works. So, uh, but we don't have the proper like machine established or the cost estimation of the product making. So we take time.
Okay. So you have collected the method so far, correct?
Yes, ma'am.
Okay. So, Chittaranjan, in your team now there are 4 people, right?
Yes, ma'am.
Okay. So you guys are which year of college right now? Final year?
Second year.
Second year.
Ma'am.
Okay. So 4 of you are in second year, right?
Yes, ma'am.
Which department?
Electronic telecommunication.
Electronic telecommunication. Okay.
Yes, ma'am.
Do you have any chemistry department in your college or something like that?
Yes, ma'am.
Okay, you have a basic chemistry lab in your college?
Yes, ma'am. Basic chemistry lab.
Okay. So you are now in third year, right? I mean second year, right? And
Yes,
what about your, your team members and you are looking for jobs or looking for PhD or like, masters or you want to go for business? Like what is your interest for you and your team?
ma'am. Uh, for startup and business, ma'am.
So for startup, all of you are interested? All 4 of you?
Ma'am. Think so, but I am interested.
Yeah, you can. Why I'm asking is when you
Yes, yes,
talk very sure about startup, then we will give you suggestion according to that. Okay, so when you say, okay, I want to do it as a project for my higher studies, or I want to do it as an experience project for my placement, or I want to do as a research for my PhD, means our input will be little different. So we wanted to understand each of your team members' future goals. So just ask them if they are very serious about this project and want to take it as a startup. That is one thing. Okay. So first thing, you ask them that and then get back to us. Second thing is, how much time are you spending on this particular project every day, or in a week? How much time do you guys spend on this?
And due to the college schedules and all, daily half an 1 hour, then 2 hour, then like in the absence of in the cause of social media scrolling, we scroll on the research papers and all.
So daily half an hour at least.
Yes, ma'am. Yes, ma'am. Average.
Okay. 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 So I have an idea now. So from your team, each of them, what role they are doing currently? Okay. So I want you to prepare this one. Each of them in your team, what is the role that you have given them to do in this project, and what is their interest, if they want to do startup or if they want to do project or intern or business, whatever it is. Like, give this, ask them that and give me the right information. Okay, by at least 2 to 3 days, just give me this information alone. This is one part of the work that you have to do. Okay, second part, coming to the PVC side, when we talk about the project, so the initial technical work you're doing, but what I suggest is you have to read some patents and you have to look at some companies. So already the companies who are doing PVC recycling, look at their videos, look at their YouTube, or look at you have studied research papers, but that is okay. You keep it for now. But reality, you have industries, you have to study the research papers. You have to study the YouTube videos and patents of these companies. They have already built this technology,
Yes, ma'am. Yes, ma'am.
right?
Like
So
the
when you
art industries and all.
Yes. So when you see these companies and you get some data, you prepare that as a report and give to us. For example, Aarti Industries is preparing this much, and they are already, removing chlorine from PVC, and they're
Yes,
doing these
ma'am.
treatments, but they have some problems, or it is not
Problems.
efficient, or whatever it is. Industrial gaps and industrial problems only we should look at. The research side, it is always going to be there. It is more of the technical part or the chemistry part. That's okay, we can figure out. But what is the real industrial gap and the real industrial problem? You have to first find out the industries, look at their patents, look at their YouTube videos, look at companies from China or from outside. Try to reach them. They are in these sites like Alibaba and all. You can just go and chat and ask them details about how this works and everything. They will explain to you. So like that, you will get details about what this PVC recycling industry is all about. Then you will know what is the problem, and then you can make a product according to that. So the area that you have chosen is good. Just this background work has to be done. Please take 1 week time to focus exclusively on the industries and their patents and the problems, and then you put your technical whatever process, and then try to come up with a full step-by-step procedure, and then you can immediately take sample and then make equipments for it and do your trials and testing. So try to work on the industrial grabs and try to talk to a few people, maybe through LinkedIn or maybe through online Alibaba. As I said, you have many Chinese machines, the companies who are doing PVC recycling also. They import these machines from there. So you can say that I am a student, doing project and working on this as a research. I want to just talk to you for a few minutes. They will definitely talk to you, right? You have already talked to many people in plastic waste, and also like that you can talk to them. So what you have to do is two things. One is ask your team what is their future plan, and what is the task each of them are going to take. This is one thing. So you will get back to me in 2 days, maximum
Yes,
by
ma'am.
Monday. And then the next thing is industry gaps and reading patents, talking to companies who are already doing PVC recycling, and what are the problems and what is your solution, what are the problems. So industrial things, you are going to work on it for 1 week, and then we are going to finish and design your product, and then you can start making the product. So this is what the plan is, right? I hope you understood.
Yes, ma'am. Yes, ma'am. Definitely.
Okay, is there any other question or doubt?
No, ma'am.
No. Okay, great. Yes, Sagarika. So please tell us the current status of your project. So I think as per our last discussion, we are trying to focus. I think we spoke to Chittaranjan and team before. So we were trying to focus on PVC recycling. So I think that was the focus. So please tell us the current status of your.
As but in recent scenario, PVC has a problematic in between the all wastes. It has a chlorine content, which is problematic and create corrodes in the industrial reactors. So now we are working on PVC treatment. We plan a clear and cost-effective solution. This have two stages. In the first stages, we are doing PVC. We are taking hydrothermal dechlorination process with some changes we are using chlorine acceptor, ethylene as a chlorine acceptor, which dechlorinate the PVC and give dechlorinated PVC and chloroethane. In the next step, we'll go for the hydrogenation process, in which step dechlorinated PVC react with hydrogen and give methane. So it is a cost effective and simple, less time taking process, which is better than other process in the recent scenario. As the incineration, PVC gives harmful emission like directional fluorescence and for in recent scenario, the PVC recycling is harmful because in the, it due to its chlorine contents, it's challenging due to contamination and difficulty to separating it from mixed waste. We are focusing. We are focusing in CPVC, which is mainly now it is using mainly in India more than 80%. So, ma'am, till now we are just planning theoretically and we also doing some industrial views industrial so we now till now we plan this.
Okay, Sagarika. So did you look into existing solutions for the PVC recycling? What are the existing solutions which are available?
Sir, incineration PVC are available. Incineration, which is problematic due to harmful emission, but our process is better than incineration because it has no harmful emission in this process.
Okay, so you are working on hydrothermal
dechlorination with hydrogenation.
Hydrogenation. Okay, so this is completely like how is this? Is this like chemical as well as physical process, or what kind of a process is this?
It is full of chemical process. First of all, PVC react with first of all, PVC react with water and ethylene. In the first step, hydrothermal dechlorination in optimal temperature pressure, and it gave dechlorinated PVC and chloroethane. And our process, one additional point is chloroethane, which is additional byproduct of our process, is also valuable for the industrial purpose. And we have in our process we have no emission.
You mentioned. Okay. So it's a chemical oriented process, right? So it will have wastewater. So have some wastewater, right?
Yes, ma'am. In the hydromet process, so we are using waste water.
When you take the PVC, from taking the PVC, what is the next step? Like you have to remove the chlorine. For that, you are using certain chemicals for dechlorination, correct? That's what you are doing.
Ma'am, till now we are planning the theoretical idea.
No, that I understand. The process
Yes.
flow, I am asking you. What is the process flow? So I am having one PVC, like the pieces of PVC shredded I am having. Assume. Okay, I have shredded PVC with me. So I am going to give the TVs. First step is chemical treatment to remove the chlorine, correct?
Yes, ma'am.
Okay, so have you designed the entire steps? That's what I'm asking. Like, what is the first step? What are you going to do? What are the list of chemicals that you need? What is the existing solution that is available? And what you can do as your MVP? So, first thing, what I would request you to do is give me the step-by-step process. Like, first, when we get shredded PVC, so PVC is available in different ways. It is in pipes, it is in water bottles, also you have PVC babies. There is a lot of different types of PVC. So what you do is first narrow down what type of PVC you are targeting first, just for a MVP.
Yes, we are focusing on PVC, chlorinated PVC, which is more harmful.
Yes, so this is type you are saying, right? I'm talking about the end product. Just narrow down the end product, like you are talking about pipes. So which type of pipes, industrial pipes or whatever, water pipes, whatever it is, it can be different. So whatever is the end product of PVC waste, what is the source that you're looking for? So that will be the first step. Narrow down that. And then what is the next step to process? Say if you take plastic PVC shredded, if you take from the water bottles, like PVC filtrate, that PVC you have to wash first. Like when we process, we have to wash it and then you have to go through chemical process and like that we will do that. When we process plastic waste, we have to wash it first and then only we recycle. Like that for PVC, you have to first wash it or then do you have to just go for direct chemical treatment or you have to heat it, whatever it is, like what are the steps? First identify the waste that you're dealing with, then what are the steps to exact steps, take down the steps. Look at the existing solutions. What is the existing solutions already available? As I said, please look into existing solutions. That is very, very important. How much it is costing? What is the processing? Because this is an industrial solution that you're building. It is for industry, so scale it. It should be scalable technology. Look at that aspect also. The first main important thing for your MVP is to design the entire process and then try to replicate it in a lab scale. So this is the first thing that you can do. It takes some few grams of PVC and soak it in the chemical. Look into how you can recycle it, make some end product out of it. That whole process you have to design. So point number one, what you can do is first look into the existing PVC technologies. What are the exact steps of the existing PVC technologies? Talk to the companies and identify them. Talk to them, ask them the pricing, ask them the steps. That is point number one. Point number two, you make your own steps. Like this is the product. This is the PVC from this pipe. This is what we're going to collect. Then we will cut it into small pieces. And then we will soak it in this chemical. That will be for this temperature for this much amount of time. Then we will heat it. Then we will dry it. Then we will purify it and make a powder. That powder you can use it for making some end product. That full chain you have to design. So first you do the market research, then you do the design of your process. Then finally we are going to use the funds to make the particular components or buy the chemicals, buy the required things for making that first pilot product. What is the end product that you are planning? We are going to use the funds to make it. So these are the three things that you have to do. Is it clear? If you do this and send it to us, I think by 2 or 3 months when you tell the timeline, when you can finish making this particular first lab scale product, then we will ask you to submit the report and then we can release the funds. So after you have submitted your process, we can release the balance of funds and you can use it to make that particular prototype or anything. Is that clear?
Yes, ma'am.
Okay, so again, I'm repeating. First step, look into existing PVC technologies that are there for recycling. Understand the step-by-step mechanism. What are the costs involved? Look into it in India or abroad also. Then go design your step-by-step process. Then you send it to us. Once you send it to us, everything is over. We will check it and then we will bring to all the balance funds. Step to make the minimum viable product. In your lab scale, take some amount of PVC waste, do your process, and then see if the output is there. That will be an MVP. With that, you can again go raise more funds, take the product to the next level. So these are the things that you have to do for us. Is it clear? You have
Yes,
to come back
ma'am.
to us.
Definitely.
Yeah, you have to come back to us with a time, like when you will be able to finish this and when you can give us. So as Vasana said, April she can finish. Like that, you have to come and tell us, like, ma'am, by March we finish everything. By March, you send us the remaining funds. By March end, we will finish and submit our book. Like that, you have to tell us. Is it clear?
Yes, ma'am.
Okay. Any other doubts?
No, ma'am.
Thank you so much, Sagarika.